Okay, hey, we're live now, right? So that's very good. So thanks everyone for being here. Let me just see if the chat's working. Looks like the chat, it's already live. So if you can hear me, if you can see me, you can go ahead and type something on the chat below. It doesn't matter where you are. It could be on Facebook, could be on YouTube, it could be on LinkedIn, you could be on our page, right? To everyone, already see here. Adam is talking. So Adam, you're saying hello, welcome all, but you're saying hello on the chat, in the private chat. There is a public chat that they can say hello to, right? So, but that's good. So I see Adam Beans already here with us in the backstage. Ruslan Sinitsky is here in the backstage. I've got like 50 plus people live right now from in all the channels. So that's awesome to have you here with us. So just say hello, right? Say hello on the chat. So I know that you can see me. Can tell me where you're from, right? Where are you watching this from? So I'm here live directly from Brazil. It's a beautiful day outside, right? And we're gonna have here Ruslan. It's coming from, Ruslan's traveling all over the world. I think he's in Cyprus right now, and Adam is in Germany, right? So I see lots of people saying hello, loud and clear. Say "sees baby." Hello, Lidio. How are you doing? Hey, Zled. How you doing? So let me see who else. Gennady, hello. North Africa, that's awesome. Houston, Tony's from Houston. David is from Costa Rica. So hi, Florent. Hi, say hi from Spain. Hey, Tatiana. How are you doing? Yanni is from Greece, right? So get people from all over the. I'm from Brazil, but live in Portugal, says Luciano. And Mabrendil says hello from Czech Republic. So guys, if you wanna say put your name in the when you make a comment, right? Because sometimes the name is not the user that you use, or anything like this. Feel free. So I say baby is from Germany, right? And there's some people here with I think from Hibres from India. That's awesome. Netherlands, Ukraine. There's a lot of people from Ukraine here that has the Cyrillic characters that I can't really read. So I'm gonna go, I'm gonna default this to Ruslan in a minute. Brazil living in Canada, says Alex, right? That's awesome. All right, so we have all Curitiba, right? The them is from here, is close by from me. All right, so we have people from all over the world. So Hussein from Indonesia, awesome. Lots of people from India, from Brazil, from Europe. Good, excellent. So Atom is from Cameroon. Lots of people from Africa too. That's awesome. So people from everyone. Silvio, it's Brazilian but lives in Chicago. So lots of people from the US too. Awesome. So thanks everyone. So we're going very well here. So let me introduce to you our host for this event, right? So the guy that's it's a good friend of mine is the guy. Look, let me tell you this about this guy, right? So Ruslan Sinitsky is the guy that I know that knows more about cloud computing than anyone else that I know, right? I mean, there's a lot of people that know a lot about cloud computing, but Ruslan, from everyone that I know, Ruslan is the guy that created a company, right? That runs cloud computing for hundreds of thousands of users, with millions and millions of hours running this thing, lots and lots of Java VMs and all of that. So I gotta say that for my friends, he's the cloud guy for me. So with you guys, Ruslan Sinitsky. Hey Ruslan, how you doing, man?
Hello, Bruno. Thank you for the warm introduction. I'm very excited to see so many people from different places of the world. So welcome and thank you for joining our session today. I'm pretty sure topic will be interesting. We have special guests today and we have very nice information. So I'm looking forward to start the session. If you are looking forward to this too, yeah.
Okay, that's awesome. So I see David Booth here. Hey David, how you doing, man? Long time that we don't talk. That's awesome. All right, so good to see you too, Hussein. So lots of good people there. That's awesome. So Ruslan, are you going to introduce the guests before? Are you going to start with a little introduction and presentation? What do you want to do?
So yeah, today we will talk about scalability and elasticity. So about basic things and about some advanced topics. So how you can use this scalability in your projects. It will be general information, so you can use in any cloud. But at the end, I will show how we built in our cloud. So as Bruno mentioned, we run a cloud company and with many data centers around the world in about 37 countries, more than 70 data centers, millions of containers are running, a lot of Java applications, many productions, and we learned a lot about scaling and about elasticity. So today, I would like to share our experience. What is the let's say, important points to take into account while designing your scaling for your applications. So, and we will discuss this topic with Bruno and our guest, Adam, like from real experience to share stories like how it was implemented in different projects. So that's basic idea, let's say. So today, after this session, you will have good level of knowledge about scaling and elasticity.
That's awesome, man. That's awesome. So let's bring us our guest here, right? So let's let him say a quick hello. So we have here today a very special guest. He's a Java champion. He's an independent consultant. He's the guy that I think like there from all the Java champions. I think Adam Bean is the one that talks most about Java in the corporate world. Java in the enterprises. So he's been for a long time a Java EE and a Jakarta EE specialist, a cloud specialist, a very prolific consultant, and he has an amazing channel where he shares his knowledge, this awesome videos. So let me bring you here, Adam Bean. Hey, Adam, how you doing, man?
Hi, perfect. Thank you. Thank you a lot. And today is one of these days where I'm actually not nervous because it's only chatting with you about scalability. I don't have to hack anything online. So it's just fun. Sounds like fun for me today. And welcome for the invitation. And of course, Bruno Souza is one of the best known Java guys I actually know. Very knowledgeable, and this is one of the few days where I see Bruno without his Brazilian flag. So I think maybe he changed, his citizenship. Now he's a citizen of USA or something. But usually he always wears no Brazilian flag. So today, not, which is somehow problematic, right?
Well, I'm in Brazil, right, man? So actually,
okay.
Yeah. So actually, this that's good. That's good. So let's say hello. So there's other people here. So Arkansas from Poland. I'm probably saying this name completely wrong, right? Eugene, say hello. Maximilian says it's from Brazil. So hello, Maximilian. So that's awesome to have everyone here. Okay. So look, we want to make this very interactive. So if you're watching this here, feel free to ask questions all the time. We want to make sure that we answer all of your questions. We want this to be a master class, right? We only to go on your problems, your questions. So feel free to go ahead and ask anything you want. But hey, the guys from JFocus are here, right? I'm not sure who is behind the JFocus chat right there, but that's awesome to have the JFocus there, right? Yelson from Colombia. Man, we have people from all over the world, so that's awesome. All right, so how about if I pass the word to Ruslan so he can get started, and we're going to be here making comments all this time, right?
Yeah, sounds good, guys. So I will share my screen. I prepared some slides. I will start from them, and then we will discuss. We'll do some dialogue between us. Okay? Sounds like a plan?
Cool.
Yeah, let me share my screen.
All right, so put your screen here.
So do you see my screen, by the way?
Yes, we see your screen, Ruslan. That's fine.
Awesome. So great guest of this session, but let's start from the topic. And today we will talk about two vectors of scaling, vertical and horizontal scalability. So you need to take into account both when you design your application. What does vertical scaling mean? It means when you add more resources into the same instance. It can be virtual machine, it can be bare metal even, so you can scale bare metal vertical as well. It's hard, but it's possible. So, or it can be container. Containers are very popular these days. So again, like vertical scaling is adding more capacity to your current instance, which is running. Vertical scaling can be with downtime and without downtime. So you can resize on the fly, adding or removing capacity, so without restarting your instance. And sometimes it's just impossible. You have to bring system down, so to add more capacity resources. Horizontal scaling works in different way when you have like one instance and you add more instances, same size, usually, like, so it can be different size, but usually people scale by similar kind of instances. And actually today, before the session, I found very interesting picture that explains what vertical scaling means with cats. So everyone likes cats. So as you can see, like in vertical scaling, your cat becomes like a tiger, right? Like a big one. So, and with horizontal scaling, you had one cat, and at the end you will have many same small cats. I hope it's clear how it works. Actually, credits goes to SysDig. I found this picture at their blog. So what are the advantages and disadvantages, let's say, of each of them? Vertical scaling actually is easier to start with. It's easier to configure. In the most cases, you don't need to adjust your source code, your application source code. Sometimes adjustment of configurations files are required for like databases to just to give them understanding that there are more resources available. Some applications, they understand automatically that more resources became available. But again, like it does not require change of your source code. It doesn't require change of your architecture in the most cases. Also, there is no need of data synchronization. And actually, data synchronization is the most difficult part usually. So with vertical scaling, data stays at the same place and you don't need to synchronize anything. And also, you don't need to manage multiple instances. So complexity of infrastructure management is very low. In this case, with vertical scaling, you can improve cost efficiency. Overhead, comparing to running multiple instances, is very low. For example, if you run virtual machine, one virtual machine, you scale it vertically. Overhead for operating system will be lower comparing if you run like 100 of virtual machines with the same operating system. Another good point, today, large memory instances and CPU instances are available on the market. For example, in the past, vertical scaling was very limited, but today you can start with 1 gigabyte and end up with like 256 gigabyte of RAM, which is huge range for scaling. And also, please take into account, vertical scaling is the fastest way to boost your performance. There is specific limits where you can not go beyond this performance limits. But again, like if you struggle from performance issues, think about vertical scaling first of all. And of course, there is no network connectivity and latency issues because everything stays in the same instance. Connectivity speed is fast. Let's say like fast as possible. Then concerns with vertical scaling, you cannot achieve availability. It's just impossible. You need maybe like specific hardware if this hardware handles failure of your instance, but still you will have some small downtime while this instance is rebooted at another infrastructure. So rolling updates without downtime is hard as well. Not every runtime stack supports updates without downtime. So it's very tricky to do without multiple instances. And also, as I mentioned, vertical scaling still has physical limits. If you reach these limits in your physical box, you have to migrate to another physical box. You may use live migration to migrate your infrastructure, like your virtual machine or container, from one smaller physical box to another one, but it requires additional technology to be enabled, like this live migration. So there is like extra complexity. Just to summarize, it's hard to migrate out of the physical limits. So this is in short about vertical scaling. Adam, do you have anything to add right now to to this approach of vertical scalability?
So this would be actually one of my favorites, because for me as developer it's very simple. And the only problem I have, you cannot just run with one host, because if the host fails, the problem is, of course, I need failover, so I will need at least 2 such machines. But from what I don't, so I'm actually for the tiger the tiger strategy, because because hardware is getting cheaper and cheaper, and from my perspective, this should be actually the future, which is clearly isn't, because people are still talking about small machines and scaling out on lots of smaller machines. But another thing which I observe is Java is incredibly fast, and our backends are extremely fast, and people underestimate actually the scalability and performance of Java, and they overestimate, or they even don't consider the problem with the backends like databases. So what I would like to add to that is that before you scale at all, you have to see whether your backend is scalable, because most projects fail because of poor I/O to the backend or slow databases. So this is usually the hard part. So back question to you: do you also see a trend where actually adding more resources to a single host is sometimes the best option?
Exactly. Look, what I noticed in the past, everyone was talking about horizontal scaling, we need to do this, and I understand why it happened, because we had limited capacity for vertical scaling, right, comparing to the physical boxes we have today. Yeah. And you're right, availability is important, for critical applications, right? But for some reason, people did not pay attention enough for vertical scaling, and it brought another problem, inefficiency, which we will talk a little bit later about this. But again, we need to think about vertical scaling when you have problems with performance, right? First of all, and think about your database. Maybe problem is not in your application server side, on your database level. So that's why I believe vertical scaling is important. But also, it's still underdeveloped, to be honest. Because what I noticed, it's not enough just add limits, more resources to the same physical box or virtual machine. You need to adjust middleware stack inside, actually. So you need to say okay, there are more resources, so take it, because sometimes you have to restart full or instance, middleware stack like JVM today. It's impossible to resize on the fly. It's possible to solve this problem, and there are some options available how to move forward, but still today it's not solved. And the same for databases, actually, right? So I believe in the future this problem will be solved, but you need to take into account that it's not enough just to add resources to your virtual machine or physical box. You need to sometimes adjust configurations file of your middleware stack.
And what I also see is that people exaggerating, and what they are doing right now, I know companies where they try to run a Java microservice on 500 millicores on a half a core. And I say, are you kidding me? Why you are doing this? And the problem with that is they think the CPU is expensive. Instead of that, if you do this, you get a lots of microservice on a half core, but each microservice needs some memory. And if I think about it, I know lots of machines with 100 cores, but it's a way more expensive to have to add more RAM to the machine, right? So what I don't understand, the cloud strategy where they say, okay, we buy cheap machines, but if you do the math, it should be actually cheaper for everyone to have beefier machines, a little bit larger, dedicate more cores and memory, and create a little bit more monolithic microservices. I don't have to run one class on a half a core. I could happily run 100 classes or 3 cores, right?
I agree. So there is some kind of balance. You don't need to go extreme one way or another way. So it's always gold middle. You can always find this middle. Yeah. Good. So enough for vertical scaling, because we can talk actually whole presentation about vertical scaling. Let's pay attention for horizontal scaling, which is the must for fault-tolerant systems, for like critical system, mission critical system systems. For example, like airplanes, they have like two engines, right? Like because they cannot just fly on one engine because something might go wrong. And they have redundancy inside. The same with your applications. Like you want to have like at least one copy of your instance if you run up production application. But sometimes even you want to scale to 100 or 1,000 of instances because one physical box just cannot handle the whole traffic. It's just not enough resources in this physical box. So in this case, horizontal scaling is necessary. So you cannot just solve this by vertical scaling, right? But we are talking again like when you go like to really, really big scale range, or when you need high availability for production or mission critical applications. So what are the concerns? Of course, designing scalable applications is more difficult comparing to just running one instance. You need to take into account how to synchronize data, how to do parallelization. You take into account latency that may happen. You need to take into account that some connection may be broken and repeat requests. Like you need to take into account load balancing. And maybe some others actually features. So complexity increases significantly with horizontal scaling. But as I mentioned, it's not possible to build a production-ready system without horizontal scalability. So Adam, do you have anything to add here, by the way? Hello, guys? Do you hear me?
This is exactly what I wanted to say, is that just vertical scalability doesn't work because we need failover. So you cannot. It would be not irresponsible to run a single node application, regardless how well the clustering or whatever works inside. I wouldn't rely on it. So I would always try to have at least two hosts for HR reasons, not for scalability, more like failover.
Correct. And the best, let's say, architects, they take into account two approaches. So because you can get best from the both. For example, when we design applications, we always think, okay, like how we can leverage vertical scaling for efficiency, and how we can leverage horizontal scaling for high availability, and maybe like for huge traffic. So this is how I would recommend you to think about it. So think about both in parallel. Good. Now let's talk about virtual machines and containers. Yeah, containers are very popular today, but we need to take into account virtual machines as well. And let's analyze how they work, and specifically like vertical scaling. As you can see, we have like simple example of virtual machine. Like gray area is overhead of memory used for operating system, memory and CPU and disk storage, let's say. Then green area is memory or like CPU used by your application running inside, or like middleware stack, right? And this red area is available resources for your virtual machine. So in the most cases, when you go to a cloud provider, you order a little bit higher than you need, a little bit more resources than you need. Like let's say like you need like 10 gigabyte of RAM, but you buy like 16 gigabyte of RAM. Because just in case if sudden load comes and your application will grow vertically, so you have this free capacity to give these resources to handle this additional load. But the issue is the following, that you always pay for these unused resources. So because they are reserved, in the most cases, they are reserved for your virtual machine. This is one, let's say, issue with virtual machines. It's like quite significant overhead by operating system itself, and resources that are not used, they are wasted in the most cases. Additional issue with virtual machines, the limits you set from the beginning, it's very hard to adjust up or down. At least at the most famous cloud vendors, you cannot do it. You have to create a new virtual machine and migrate your infrastructure, I mean your middleware stack inside that new virtual machine. So this is what we have today. Still, some vendors or some solutions offer adjustment of virtual machines on the fly. It's called like ballooning. But in the cloud, it's not. I don't see that people use it often because honestly, it's a difficult technology. It's so you might face some problems, and service provider just don't offer this solution today. With containers, situation became different. First of all, overhead became slimmer because you don't run dedicated operating system for every container. So they share the same operating system. They share a kernel. So overhead is very small comparing to virtual machines. And then again, like we have the same application or middleware stack that is using some kind of some resources like green area. And the unused resources up to the limits, they are shared with the same containers that are running on the same host. They share it by default. They're available and share it with other containers. So it means you can use this opportunity to put more workloads if you handle this properly. This is one advantage of containers. And another one advantage, you can adjust containers on the fly without restarting the container. Not every again like solution offers this, but it's possible and it's much easier and simpler. It's available by default for containers. So now we get these containers and they became more elastic and more advanced comparing to virtual machines. And if you do comparison how it works, for example, virtual machines and containers, as a summary, right? Like you started from small virtual machine, let's say like 8 GB of RAM, but you used like 4 GB of RAM, you waste some resources, but at some point your application started to grow and you need now 10 GB of RAM. However, you have to buy twice more, like in the most cloud vendors, you cannot just add 1 or 2 GB of RAM, you have to buy twice bigger virtual machine. And then you have to migrate your workloads from old virtual machine to a new one or reprovision from scratch. And then do it again if you reach the limit. With container, it can be different, right? It's scalable vertically, up and down, on the fly, and resources are available and shared with other containers. So this is in short about virtual machines and containers, the difference. Adam, do you have anything to add here, interesting, or your experience working with virtual machines and containers?
Yeah, I actually wanted to ask you because I hope you are still associated somehow with Jelastic, right? So the question is, actually the best solution would be, as you said, horizontal vertical scaling. So it would be possible, you have, the main host, which is beefier with a reasonable amount of CPUs and RAM. So, and then have, the failover host, which both could run in containers, and the failover host would have a smaller amount of CPUs, but we could actually on the fly dynamically add more CPUs or RAM on demand. So if the one fails, we can have no failover to the other one. So this would be actually a nice thing. And what I wanted to add, it is even worse what you said in most providers. So if you take a look, for instance, on some Kubernetes services, what you will have to do is you have to order the machines first. Then you will install, the Kubernetes environment on this machine. So if these machines are not enough, your worker nodes, then you will have to reinstall the entire Kubernetes cluster or add, it's even a little bit harder if you're dealing with Kubernetes. With plain containers, you are right, you will have reprovision, you will have buy different machine size and install the ECS on that machines, right?
Correct. Yeah. So you touched a very good point actually. With Kubernetes, if you did a wrong guess at the beginning, you may spend a lot of efforts, like to adjust this later. So yeah. Cool, but let's talk a little bit more about how it works behind the scene.
Ruslan, just give me a minute. I think this is a good time to ask you. So hey, I just say hello to Ivan. He's a Brazilian living in Portugal. But Hussein asks, what is the most difficult thing about Java? And every time we talk about containers, one of the things that people come up a lot is that that Java has some kind of problems. That when you create containers, Java is very memory hungry, so it doesn't return memory back to the system. Is this like one of the big problems that Java has in terms of using containers in terms of scalability?
Oh yeah, so Java at least had the big problem with elasticity, like because everyone knew that Java is greedy on memory, right? Like it consumes a lot. And actually, what happened recently, the problem was solved. Literally, like so, the problem is solved. The Java now is elastic and it's less greedy. It may be still, consume more RAM comparing to like some others, but again, like it only at the beginning. Like when you run like big production, mostly other scripting languages they will consume even more than Java. So, but what was the problem? Like the problem was the following: as Java was designed like in the past for to run inside virtual machines or to run inside like bare metal, nobody pay attention a lot for this elasticity vertical scaling. And also, what people did in the past, they put multiple applications inside one virtual machine. So somehow, like Java could share this memory like heap between these applications. But today, people mostly run like one applications on top of multiple Java instances, right? And inefficiency of Java became a problem because like you waste a lot of resources that are just sitting and nobody is using them. What was the solution? Actually, our company, my team was researching this topic actually about 8 years, I believe, something like this. Yeah, and we found a solution and we created a patch and contributed this to OpenJDK. And after this, Java became much more elastic and less greedy on memory usage. So you just specify one parameter and then Java can go down. So in the past, it just can go up and stay like this forever, even if it does not need this memory anymore. But today, when memory is not necessary, Java releases memory back to operating system. So this feature is available from Java 12. And you can write like Java elasticity or like state of Java elasticity, and you will be able to find a very detailed presentation about this because I evangelized this improvement last days, and it's because it's very exciting because Java became more efficient. And what happened after this? Other vendors that developed in-house this elasticity stuff. Actually, what happened? Like many vendors had this implementation in commercial solutions of Java, but after this became publicly available, elasticity and patch, other vendors decided to open source their solutions, and they introduced elasticity by default in almost every modern garbage collector. Like ZGC, Shenandoah, Alibaba has own implementation, as I know. Then Azul system, they have own solution as well. I believe it's not open source, but still, like it's elastic. So today, just to summarize, because I can talk a lot about this, but today the problem of Java efficiency has been solved. Java became more elastic and more efficient. So pay attention on this, or you can enjoy these benefits.
That's awesome, man. That's awesome. So, because Baby says, asks which version of Java solved this, right? And also asks, he makes a comment that most companies use like Java 8. They shouldn't, but they do. So, so is there a specific version, Ruslan, that this thing solved?
Yeah, so it's Java 12. Guys, you can help to bring this to Java 11. Right now is the fight, let's say, but it's a like friendly fight inside OpenJDK community about backporting this feature to Java 11 at least. Not we're not talking about Java 8, but at least to Java 11, which is long-term support release. So please help us, request this feature on your Twitter, like in social media, demand this, and it will give us more reasons to backport this feature to Java 11. Because right now we have some kind of, concerns, should we bring this back or not? Some people say maybe it's not so important. Other people say no, it's important. It saves a lot of efforts. Resources. For people, it improves even performance. We need more voices, from end customers. Please go to Twitter, social media accounts if you are registered even in OpenJDK channel, email channel. send your request, like demand this feature. Like, so it's not hard to, honestly, it's not hard to backport to Java 11 and work almost done. It's just political question now.
All right, that's awesome,
which
man.
JEP is it, Ruslan? Which JEP is it, or was it a patch? What you contributed?
So it was like Java hotspot, Java dev. So I can send you a specific channel, email channel. But if you see, let me show you JEP.
Because I think what they also asked what Java fixed in JDK 10 and was backported to JDK 1.8 is the issue where Java see now, the container memory. So this is already solved, long solved problem. So this is not about elasticity, rather than you can say Java should only use 80%. Java should only use 80% of the available container memory, and this will work. So this is not a new feature. It is a JDK 10, I think, feature, which was backported to JDK 8, right? But you are referring to something even better. So like,
exactly.
The elasticity for RAM. So I think what Chad asked was the basic feature, and this feature you're searching right now, it is either a JEP or a bug fix, but you will share it in the chat. So interesting.
Yeah, correct. So like there is a link to JEP. It's JEP like 346. It's
Okay.
like original improvement, which was released with Java 12. And there is a backport. There is a conversation about backporting. I cannot find it right now, but I will send it after the talk. Yeah, but it should be over.
This is the JEP. Okay, it's good.
Yeah, we can send all this information. So actually, this is a good time for me to just say this. We're gonna send all this information, and I'm sure there's gonna be a question about this in the chat in a minute. So we're gonna send all these slides, all the information, all those things. We're gonna send for everyone that's registered, right? So if you're watching this and you're not registered on the Cloud Tech Days initiative, let me quickly give you the link here. So we're gonna have this whole week, right? So register right now on the Cloud Tech Days, cloudtechdays.com. If you register there, you're gonna receive the slides. You're gonna receive this information that Ruslan is talking about, and other cool information. And also, you're gonna be notified every time that we go live this week, right? Because this week we're gonna have 3 main meetings. That's gonna be today. That's the one that's going right now. Then on Wednesday, we're gonna do a discussion about saving money on cloud computing, and on Friday we're gonna talk about simplicity, right? So how or complexity, right? The both sides, simplicity and complexity of cloud, right? So we're gonna do these 2 things this week, right? And so if you want to join this, if you want to participate in all of that, please register right now, cloudtechdays.com, so you don't miss any of that what we're doing here, right? And I know some of you already registered there, but maybe you're watching the live stream and so you're not registered. So go register right now, so you're gonna receive all of this information, right? So Ruslan did put here on the chat. So can you put these on the you're gonna put these in the public chat, Ruslan?
Yeah, please, yeah.
Yes.
So you can see there is a thread, like conversation, like we're trying to figure out like how to speed up this, like and what are the concerns. Concerns are the following, like and actually there are good concerns, like the people want to have stability, right? Like the main concern, like they say, like maybe we don't need to do this backport because we don't want to bring any risk to influence stability and so on. Like which is reasonable, absolutely. However, like the real amount of backport and code is very low, and there is a big commitment from Alibaba, from our company, from Microsoft to do proper testing before we do it publicly. So we really need more voices. We really need more people who can even review the code, like to make sure the quality is good. So if you can help in any way, and you can help by demanding this feature or like reviewing the code, please help us.
And
right, so
what I also wanted
to put right there on the chat. So the link that Ruslan is talking about, this online discussion, I'm also put on the screen, but I know it's going to be hard to type. But if you go in the chat right now, you're going to see the link, so you can actually go there if you're interested in this discussion.
What I just wanted to quickly note also about Java and cloud. So some projects are really in, I would call, schizophrenic, situation, because what we did with Java at the beginning, Java was slow. Now it's incredibly fast, and now we hear it doesn't have to be that fast. So Java optimized a lot at the beginning, so we need more memory, right? But with the serverless movement, they say, okay, now it doesn't matter that Java is so fast. We would like to start fast. So, and if you would like to start fast, then you can cross-compile Java, but there is no, optimization all the time. So Java can be even slower, but it's highly optimized. So everywhere are trade-offs. So what is interesting about scalability is also to think, have one larger machine which runs with more memory all the time and is very fast. Or I would like to have serverless-like environment where the functions are coming and going. There is not they just consume a little memory, but they are not fast at all. So this is also interesting regarding scalability, how you would like to scale and how much money you would like to spend, because serverless is not always cheaper than a beefy machine. So we do the math several times, and it was only in rare cases cheaper for toy apps. They run once a month or something like this, right?
Correct, Adam. So yeah, definitely, look, you need to consider what is your goal first of all, and what approach you want to use. You can use both of them to achieve your goals, and just choose that one that brings you faster to your results. Look, I don't honestly I don't force or don't try to insist on specifically my approach, right? Because I prefer combination of both, vertical scaling and horizontal scaling.
Yeah.
Some people they go only for horizontal scaling and they don't pay attention at all for vertical scaling, right? I don't care. Look, if they solve their problem in this way, and they're fine to pay a little bit more for unused resources, it's fine. Look, it's their own decision. So we have different options. People are different. Minds are different. So, but again, if you know that there is one option, another option, you have more possibilities at then.
Well, you're perfectly right, but in reality, there's more about fashion. Not always everything is problem solving, So that's the problem, actually.
I agree with you. I agree. Yeah, so fashion, and some people insist on one patterns, and then this pattern become outdated, and they invent another pattern.
Yeah.
And
exactly.
They use new patterns. They after time they come back to the first pattern and say no, this one was better.
Exactly.
So. Okay, look, think about your problem. What is the problem you want to solve, first of all? That's number one.
Exactly.
Good. Little bit more. Let's talk
All
about
right, so,
different.
So Ruslan, before you go next, right? So what I believe is Hatana, right, is asking here how to vote for the pack, right? I think you said something about going online on Twitter. How do you actually vote? So this patch can get supplied to Java 11.
Okay, very good question. So there is one guy, let's say, who should take responsibility, to accept this patch. His job is very responsible, yeah, and you can find him here. So Alexei actually is reviewing this patch. We need his feedback right now, or feedback from other guys, and there is Andrew. So Andrew is the guy who will decide what to do with this patch at the end. So you can find his Twitter, and say Andrew, please, we need this patch. Maybe you can do this way, but please be friendly. So it's really it should be professional. We don't want to to scare people, or it's just just say I'm looking for this, I need this, and it will be it will be just good to let people know. Or subscribe to this channel and submit your specific need, why you need it, and why you believe it's good. So because I believe everyone can subscribe to this channel. It's open source email communication for open source OpenJDK, let's say, yeah. So you can subscribe and send messages as well.
Right. So basically, here's what we're gonna do, right? So someone said, yeah, you have my email. Yes, I know. So if you register here, you're gonna receive an email explaining how to do those things, and you don't even need to. If you don't even need to vote, if you send to us Hatana, if you send to us on the email that you got, once you register, you're gonna receive an email from me, an email from Ruslan. So when you do this, you can just reply to that and say, look, I need this patch because of this, this, and this. My company has this particular problem. So tell us what the problem you have that would be cool for you to be able to do this on Java 11. And then we're going to talk to you. We're going to help bring your needs to OpenJDK. So we can make it very easy for you, right? Okay. So let me just say
Good.
hello to Fabio from Saving Cloud, right? It's a good friend here from Brazil, right? And Saving Cloud is a partner of Jelastic. So good to see you here, Fabio.
So a little bit more about how elasticity works behind the scene with containers and virtual machines, and why actually I like containers. It doesn't mean I hate virtual machines. I like virtual machines as well, like for some specific workloads. But with containers, at least we can do just more stuff. And look, we have like two hosts, like container-based and virtual machine-based, right? Like when we have, let's start from virtual machines. When we have like virtual machine, our application usually doesn't consume everything. So there is a free empty space. And this space is reserved for each virtual machine. And this space is only available for this virtual machine. Because in the most cases, it's just reserved for this virtual machine. So this free resources can be shared only with the applications that is running inside this virtual machine, right? So it's very limited possibilities to scale up and down. With containers, it works a little bit different, as I mentioned, because containers, they share by default unused resources with other containers on the host. It means like if you have the same size applications running in containers, all these free resources, they will be available in the shared pool of resources, right? And what happens when one container starts growing, so the container gets these resources from the pool. And as pools are huge, you have much bigger range for scaling compared to virtual machines, right? And usually what happens, like containers, load goes down, like containers go down, and then these resources will be available for another container. So of course you may happen, like what happens, you may ask what happens if all containers started to consume. Look, usually it's enough spaces to do extra preparation, like for evacuation of containers. Like if container starts growing and the limits of available resources come close to the specific threshold, usually it's like 80%, right? Like, so let's say like 80% of resources on the host machine are busy already. So you do live migration of containers from one physical node to another one. It means like no containers go down, like you distribute the load across the cluster or across the physical nodes, and you still have this capacity to grow up inside this one host machine. So this is usually how it works. Not everyone understand, and I believe serverless approach was driven by service providers because for them it was really hard to handle this like live migration and capacity adjustments. Like, so for example, when they need to upgrade infrastructure, the easiest way for them just shut down like all host node with all containers inside, like, and reprovision them on another host. Like, so, but it's possible to do it in another way with live migration because you can evacuate all containers to another host node and do this maintenance without visibility to end customers. But it's very, very advanced technology. So let's say like not everyone can use it still today. Good. And as an end customer, you don't need to worry about this. I just wanted to explain how it works at the back end of advanced cloud service providers. And then container horizontal scaling is the best actually because you don't scale inefficiency as you scale with virtual machines, because these resources, they are unused and they can be used by, unused resources in one container can be used by resources, by containers, by another container. So efficiency is much higher with containers at the end. Good. And one more theoretical question here, stateless and stateful scaling. It's opinionated topic, I would say, right? tell you what is our and how we work with stateless and stateful approach. So what does it mean, stateless? Stateless mode means when you scale, you create completely new container from container template, right, from container image, and it's empty. There is no data inside. I mean, persistent data. There is some pre-configured software stacks, software runtimes, right? But there is no data, and it's much easy to. I mean, it's easy to scale in a stateless mode. And usually, how it works, you create new containers. If you have like cluster, physical cluster, let's say like 100 physical nodes, right? And you create like hundreds containers. A good system will put each container into a separate physical node. Because if one physical node fails, only one container will fail, right? And stateless mode, again, like it's the simplest way to scale applications. There is another option like stateful. And what does it mean, stateful? As you can see, we illustrate this by like white, it's mean empty, but stateful, it's blue, it has state inside. So in our case, when we call stateful, we literally copy all data from master container. Data, I mean like what is written on file system, I mean what is placed inside the memory even right now. So we copy the full state which is running inside this container. And what we do for improving availability, we copy this container on the same physical node host at the beginning, and then we migrate this container to another host to achieve this availability as well. Stateful scaling, more complex. It takes longer because you need to clone the state, right? Sometimes it's even hard or even impossible if you have like a lot of data inside, right? So you need to rethink about this. You don't need to clone like terabyte of container. Something wrong, like if terabyte of data is located inside your container. Yeah, but if you run, let's say, like gigabyte, like 8 gigabyte, even 16 gigabyte, it's still fine. Like you can clone this and migrate to to another physical node. And what is beauty of this? All your configs that you did inside like this master container, you don't need to repeat them. They will be automatically replicated to another to your clone instance. So in some ways, it simplifies. But you need to be careful as well because you need to take care about synchronization after. So you need to have some kind of shared storage or to implement synchronization, use like specific software to synchronize the data. So this is in short about stateless and stateful approaches. Adam, I would love to hear your opinion about this here because it's really opinionated topic, specifically stateful. What do you think? Do you have anything to add?
I mean, if I would get it and it works, it would be perfect. I give you a recent example. So I'm rewriting my blog as because I like to, and I decided to store the files on a local file system. It's actually, and I also recorded a micro-profile training, a workshop, how I did it. But so it is in a folder, and of course, on Kubernetes, I will have to think about attaching disks or whatever. But if this works well, then I can just rely on the replication. So I would just get an exact copy of the files, and not a lot, to the other host. If you said that the entire data system is copied, and I get immediately another idea in mind is bug fixing, right? So if I could get a copy of the production machine for offline usage and investigation, this could be actually this is a killer use case. You know what I mean? Because you say, okay, create a snapshot right now. Give me the machine. The machine is offline, and I can investigate on the machine. So this would be also interesting use case for stateful scaling or stateful capabilities. What I wanted to add is that that actually everything is stateful, and the whole stateless hysteria only became because it is harder to build a cloud around that. And at the beginning, I was always criticized, what about the session or whatever? So, okay, we can store the session in the database, but it's not like there is no session anymore. The problem is the sessions in the database. And why memory is slows worse than a database. So if this works, I will of course use it, because now the entire stateless idea is just because most of the provider servers just can do this. And the whole idea of the session affinity and sessions was that it is more convenient to use if I have my objects and I can rely on the objects in memory. And what I never understood is the hardware. It goes in the directions, and I think in a few years there will be no distinction between RAM and persistent storage. We already have, the Intel Optane or whatever the technology is called. So actually, the future should be just to work with Java objects, which are always in memory, and the memory is persistent.
Correct.
This is the ultimate, productivity solution. They're not fiddling you with, storing and getting the state, and then. This is why it was misunderstanding at the beginning, or misunderstanding. So if we scale horizontally, what we scale, most of the Java applications are enterprise applications are trivial. We just interact with a database. So if we just start more and more CPUs at the front end, nothing goes worse or better. We just pulling the state all the time from a database.
Correct. Yeah. So I agree with you. Look, this stateless approach was, from my point of view, like overhyped, let's say, yeah, because like there is in reality there are no production applications without state, like maybe like calculator, like but you keep state in the database, right? And now what people want to do is they want to run databases in containers as well. So what to do, like where we should now move to the state. So we need to have stateful containers for this, right? And I understand what you mean about Kubernetes, but look, Kubernetes is still like early days, right? It's still improving and developing. Like it's a good solution, but it's not the end today. Like, I mean, they will improve, and there are other solutions. For example, you say like if it works, I will use it. Elastic, it works for many years already. And we do it for Java enterprise servers. We do it for databases. We run databases inside containers, and we can scale databases horizontally. And this is exactly how we do. Like we clone master node, we migrate to another physical node, and then we sync up data. So you don't need to think like about this anymore.
This is great. Kubernetes was not like a feature what I mentioned. It was more a limitations of what Kubernetes you will have to ask. You have to specify the persistence volume claims. So the data wouldn't be in the container, the data would be somewhere. And the problem with somewhere, for instance, it works really bad with, let's say, a Kafka, because the link between the container and the persistent storage is always too slow, or in most cases too slow. But if the data lives inside the container and I can just clone it, and if you manage to do that for me, this would be, of course, great, because then I have the copy of the data and not a reference to the data on a central hard disk, right?
Correct. Yeah, and performance will be better because, like, if you attach like remote shared storage, like, so it will slow down your performance. Yeah, but if you keep data inside container on the same physical host, performance will be better. But again, like, there are some kind of pros and cons. You need to be careful. Like, of course, this is the reason why I'm explaining you like what kind of options are available. You need to think and keep this in mind. And actually, Adam,
one question about live migration. What happens if I still interacting with the master? So in one point of time, you will have to do clear cut. Now it's enough. Now the other is the master, right? So you know what I mean? The problem is always in-flight transactions.
So you mean like it's keep writing, right?
So I'm writing to the master, and I would like actually to clone the data to the. We have the follower and we have a leader. There are no more masters anymore. So we have follower and leader. Right. Mm-hmm. So I'm writing to the follower, and I would like that the leader becomes the follower right now. So in this particular case, you will have to say, now all the traffic to the leader, and now we are offline for a few seconds or a few minutes, or something have to happen in between, right? That's the technical challenge I see. Not my problem as developer, is your problem as a cloud provider.
Yeah, I can tell you like how it works. There is another presentation about live migration, so you can print in Google like Elastic live migration behind the scenes, I believe. Yeah, and we exactly explain how it works. So there are two approaches how live migration works. But usually, look, we start the copy data, right? We copy data which is not hot. We move this data, and then we do like synchronization, like little by little, like, you know, if master still accepting requests, like so, and we keep synchronizing till this delta is very small, like, you know, and at that last point we say like freeze everything, like till we synchronize, like, you know, it might be some glitch, but it's very minor, like, you know. So it's acceptable, like maybe like less than a second. Again, like depending how fast it's written, data is written to master. There is another possible solution to design, like, for example, you have master and you have, let's say, like lead and follower, right, in the correct way. So you clone follower, not a master, and you connect it to the master again afterward, like, you know, it's another possible way to do it. So it depends how you want to implement.
Okay.
Cool. Good. So as a summary, vertical scaling. By the way, like, what is another good point about vertical scaling? Why I like it very much? Because there is a big problem in the cloud about sizing, right sizing. Like, when you start your application, you need to think in advance how much resources you need to reserve for your instance, for your virtual machine, like, right? How much resources you need to get from cloud service provider. And in the most cases, it's very hard to predict because you don't know exactly how much it will be consumed by your application, or what will be the traffic today, or what will be the traffic in a week, right? Or what will be the traffic in Black Friday. So, and it means you are in the middle between, like, okay, buy less, save money, but there is a risk to go down when traffic goes up, or there is another risk, like, you know, to get more resources and overpay for them, like, because you don't utilize everything. And this is the problem of right sizing. Vertical scaling solves this problem, but not only vertical scaling, with specific additional approach, which is called like pay per use. So if you combine both, this problem can be eliminated at all, because like you can get big limits. You don't care anymore about like unused resources, because you don't pay for unused resources, only for what you use. Like, so you set like high limits and you are secure. So no downtime, and you don't overpay. Like, it's ideal world, like where we want to be as a cloud in the next, you know, like I hope it will happen soon. More cloud vendors will join this movement. Yeah, but vertical scaling is the base brick to solve the sizing problem. Good. Then also vertical scaling, we have just a summary again, like we have big range today, like comparing to the past, right? Like, and memory becomes faster and faster. I mean, cheaper and cheaper in addition. So it's much more advanced now, vertical scaling, comparing to the past. So actually, there is a summary of how it works inside Elastic. Yeah. And there is a possibility to do adjustment on the fly without the restart of your instance. So you can add or remove memory to the same container, which is very convenient, right? And now summarizing about horizontal scaling, is solving heavy-ability problem. You cannot solve it in another way, so you have to do like 2 or more instances. It's possible to do automatic clusterization, so sophisticated system or advanced system provide you tools. Just click a button and it will cluster your instance. For example, it's a database, so it can cluster in a scheme like master, or like Galera when like only master, or like leader and follower. So there is again like solutions in the market that automate this complexity for clusterization and load balancing. And there is a possibility to create automatic scaling, horizontal scaling. So you define just triggers based on CPU, on RAM, on disk space, on traffic. And the most cloud vendors offer this. And you want to do automatic stuff. Like sometimes you need manual, right? But you want to have stuff done automatically, because you don't want to wake up during the nights. Like, so discover automatic scaling options at your cloud vendor. Think about stateful and stateless scaling mode. Not every vendor offer stateful approach today, but still, like, if it's available. It's not a secret, so it just requires extra efforts from service provider to get to this level, but you can demand this. Anti-affinity distribution is a must for horizontal scaling. So when new container or virtual machine is provisioned, it should be placed to another host comparing to the original container. And this is in short about like summary. So any questions so far, Bruno?
Hey, Ruslan, that's good, man. That's awesome. Awesome discussion. So let me tell you a little bit. Let me go to the chat for a minute here, and then we're gonna bring Adam back here. So we actually have the so if you're watching this here right now, there's two things that I want to tell you. The first thing is, if you are not registered for the Cloud Tech Days event, I'd suggest you to register right now, because we're gonna send you. Everyone that's already registered, we're going to send you the links to this presentation and more material so you can rewatch those things. So come here right now on cloudtechdays.com so you can participate more in that. And if you have any questions about all of these, so I can see Constantine. So hey, Constantine, so good to see you, man, from Burkina Faso. That's awesome that you're here. I also see Pema from Bhutan. So awesome, Pema, that you're here. That's so good to have you here. So, go there, register on cloudtechdays.com, because that's going to help you, participate on all the other meetings. We're going to have meetings on Wednesday, meetings on Friday. We're also going to have some content on, tomorrow, Tuesday, and also on Thursday, we're going to have some small content. We're also going to have lots of material to be sent to your email, so you can have all your questions answered about the cloud. And if you have any question now, send it to us so we can answer here. And actually, one thing that I want to do really quick, let me bring back. So let me get here. Let me bring back Adam. So hey, Adam. So thanks a lot for being here with us today. And I know you don't have a lot of more time, so I'm just gonna want to do this be quick. But also let me get here another guest, right? So on Wednesday we're gonna have another Java champion participating with us. That is Rafael Del Nero. He's responsible for a lot of Java challengers. So he's going to help you really improve your skills on Wednesday. So Rafael is here. Hey, Rafael, how are you doing, man?
So, hello, everyone. I'm doing great. It's great to be here with you all, Bruno, Adam, Ruslan. Amazing to be here. It's
Hello.
Also nice to meet you, Adam, because I don't think we talked before.
So, no, not yet, but now we're talking,
Yeah, now we are talking, yes. Nice to talk to you.
Yeah, so thanks, Rafael, for joining us a little bit here just to say hello and be ready for Wednesday, right? So that's good that Rafael is here. But, let me go back to the chat here. If you guys are watching us, you have any questions, please throw in the chat. I see local for Java. Hello from Brazil. So, we are all locals for Java here, I think, right? So, Paulo says, DLS can be installed on premise, or is only licensed to cloud providers? Are you planning a do-yourself package in the future, Ruslan?
Yeah, so about Jelastic, actually stay a little bit longer. I will show a little bit more about Jelastic, how it works, because we were discussing general things, right? But now at the end presentation, I will focus how we did it specifically, because there is some differences compared to other solutions. Talking about installation of Jelastic. Jelastic is a software, right? It's a software that can be installed on top of bare metal infrastructure, and it converts these bare metal clusters to cloud. In addition, it can be installed on top of public cloud vendors like Amazon, Azure, Google, or OpenStack, VMware, so everywhere, because Jelastic is a multi-cloud platform as a service software. Yes, it's available on premises as well, in other words. And you can build again hybrid cloud, so you can connect to your private data center. You will have your cloud, connect to all this expensive or inexpensive cloud vendors, right? And you can even rent or collocate infrastructure somewhere and connect to the same cluster. And the best thing, you will get the real interoperability. So in the same way you deploy to on-premise your application, right? In the same way you will be able to deploy to Amazon, to Azure, to bare metal collocation. So it's real pure interoperability. Now talking about OSS packages and Open source. Look, we started movement to open source. It's very complex exercise. We open sourced our packages specifically like clusters for databases, for WordPresses, for Jakarta AE applications. You can go to GitHub and print like Jelastic minus GPS, Jelastic packaging standard, which is called collections, and you will see a long list of packages. So you will be able to see like how we build clusters, how it works behind the scene. We also open sourced some modules of our project, specifically like UI, so our dashboard is available. Also, some specific advanced logic that makes containers smart. We call it Jelastic Environment Management. It's open source as well, and there are other modules in the open source. However, there are some modules are closed because, look, I believe we are still not a big company. I hope it will be solved. We need more capacity to handle properly open source movement because it's just not enough to open source the source code, right? We need to handle it properly, to engage properly community, and to move it forward properly. Like so, otherwise it will not work for anyone. Like so, that's the current state. But in the future, we plan to move, and we are moving step by step into open source direction. But today, again, like we support like all open source, the most popular open source software stacks, and we evangelize open source. Taking account size of our team. I hope I answered the question.
Okay, that's awesome, man. So how about you, Adam? I just want to give you enough time for you to say whatever you want to say before you have to leave, right? So is there any comment or question or anything that you want to talk about this whole thing that you're mentioning here right now, Adam?
Yeah, just to the audience. So if they would like to hear or even hear how Ruslan or Bruno actually started their career, so there's an AirHacks FM podcast, and I performed some freestyle conversation with both of them, with Ruslan and with Bruno. And if you would like to know what the first computer was of them and whether they played a lot of games or were really focused cloud developers from the beginning, you should listen to the AirHacks FM podcast episodes with Bruno Souza and with Ruslan Sinitsky.
Yeah,
True?
That was very, very good conversation. Exactly, like so.
Yeah, it was a lot of fun. So the conversation with you was published yesterday, and with Bruno, I think last year or something like this, right, Bruno?
Yes, exactly. We had a conversation right after Oracle Code 1. It was awesome, right? So actually, let me do this. And I'll put Adam's AirHacks podcast here on the screen, right? So let's see. All right. So if you want to go to airhacks.fm, right, you can see there on the screen right now, and that's where you can watch amazing podcasts. Because one thing that I love about Adam's podcast is that he really talks with all his guests, right? And he goes with all kinds of discussions. It's a very open discussion, and he kind of probes the guests to reveal all kinds of secrets. So you really should go and subscribe and watch airhacks.fm and see what Adam is doing there. That's awesome. And actually, it feels for me that Ruslan was there yesterday, so that's good.
There was probably the most, Secret Service James Bond-like podcast was with Ruslan. So just, if there are secret places involved we are not allowed to talk about. So this was actually really interesting. And
yes, exactly.
One question to Ruslan before I have to sign off. So you made me curious because what you said is that you can able to add more memory and hopefully more CPUs on the fly. This is correct, right? To the nodes, correct. To my machine.
Exactly. So, but to container.
Mm-hmm. Yeah, and you do you have a kind of API where you can do it from outside?
Correct.
Or,
yes.
Because what usually happens is in such scalability. So we have lots of metrics, and we know what actually in a great microservice or cloud native projects, we know what the application, how it behaves, and we can expose lots of monitors. For instance, with micro profile metrics, you get the possibility to expose a lot. So what you could do actually, you could listen with a kind of watchdog outside the application and watch what is going. Something like Kubernetes, the orchestration, but not in multi-container, just per container orchestration. So I can watch my own app and see now we have a spike, so I can dedicate more memory and more CPU. And then after the spike, I can say, okay, now I can deprovision, the CPU and memory and let the application breathe. So it's not like scaling between nodes. So what lets one node be faster and slower on demand. This will be possible, right?
Exactly. This is possible right now with help of Jelastic. So we have APIs, we have working solution. If we are talking about Java, there is one bottleneck at the moment, because like if you start Java with specific limits, right, you cannot go higher with these limits. Like that sucks, unfortunately. But like there is a solution actually for this. We have a solution. The question is to push the solution and accept by the community, because there is a possibility to solve this problem, then Java will be able to adjust on the fly. So if you wish, we can set up another talk and I can explain you about this adjustment on the fly, like kind of APIs, how Java should be handled inside, and maybe together we can come up to to some kind of innovative, unique solution for community. For Java,
who knows?
It will help. Exactly.
Yeah. So thank you. After clarifying, how Jelastic works, I have to sign off. And I wish you all, have lots of fun with Cloud Tech Days, and enjoy Java.
Before you go, Adam, let me just tell this, that a lot of the things that you just mentioned right there is, we're going to talk more about simplicity on Friday, right? And there's one cool thing about Jelastic is that you can configure things in a way that your container is going to grow and reduce, and you only pay for what you're using, right? So that's a cool thing. And then you don't have to worry too much about increasing or decreasing memory, because you're just going to let Jelastic handle that for you, and they're just going to charge for what you use. So we're going to talk more about this on Friday. But Adam, thanks a lot, man, for being here. It was totally awesome to have you here. And thanks a lot for interviewing me and Ruslan and lots of other people in your podcast. I really enjoy every time you have a new podcast. And I've got to watch this from Ruslan because I was so busy yesterday I didn't see that one. But that's awesome. So thanks a lot, Adam.
Thank you.
Thank you.
Bye.
Bye.
All right. Thank you. So, and one thing that we're gonna do, I know Rafael has to go to, because I just want to thank Rafael for joining us here for really quick, because Rafael is going to be here with us on Wednesday, right, live, talking to all of you guys. And Rafael, is a guy that talks about challengers and how you can improve your career, how can you be an awesome developer. So he's going to tell us a little bit about how can you be an awesome cloud developer on Wednesday. Right. So thanks a lot, Rafael, for being here with us.
Thanks a lot, guys. It's great to be here.
All right.
Thank you.
Okay.
Bye.
So I'll let Rafael go. Thanks a lot, Rafael. Awesome. So that's good. So Ruslan, let me see. Let me go back to the chat here and see if there's anyone else. I see Paulo says, thanks, man. You got this. Right. So I think Paulo is very excited about you're talking about open source and do it yourself kind of thing. That's awesome. So let me see if there's any question that I miss here. So if you have any questions right now, I think I would suggest you to ask questions, because we're getting to the end of our first masterclass here. But before I get Ruslan talking a little bit more about the masterclass, let me just kind of say you one more thing here. If you're watching this here, if you're watching on Facebook or LinkedIn or YouTube, whatever you're watching this, if you're not registered for Cloud Tech Days, I would suggest you to go here, cloudtechdays.com, and you can register, because right after we finish here, we're going to send to you, the slides and the material and some more information to help you grow your cloud skills. And also, once you register, the cool thing about registering is they're very simple. Once you register, you get an email from Ruslan, you get an email from me, right? And so because you do that, so you have our contacts, right? So you can send us questions, you can send more information, so we can help you out, because we're really interested in helping you create, and get this your cloud projects going on, right? So anything that we can help you out with this, it would be totally awesome, right? And the last thing I want to say is, well, that's it, right? RashForCloudTechDays.com, right? And let's see if there's any more. So we have more questions here, looks like. So Lidius says, okay, so let me get Ruslan back here. All right, so Lidius says, fantastic conversations. Thank you all, right? So, that's awesome. And so basically, local for Java is kind of clapping, right? So thanks a lot, local for Java. So that's good. Awesome. So basically, Ruslan, I think that so Yosef says, how to convince a small client to use Zabbix? So I don't know why Zabbix particularly, right? But let's kind of change this question around, Ruslan. And he said Jelastic, right? So, okay, so he typed it wrong. So the question is not about Jelastic in particular, Ruslan. I think a cool thing that we have to ask a lot is how to convince people to use the cloud, right? Why should a small client use the cloud and maybe use Jelastic?
Correct. So that's a good point, because look, cloud is all about, first of all, elasticity, right? So you can start small and go big. It's about scaling. Like if you don't need scaling, maybe maybe it will be overkill for you. I cannot say there is no silver bullet for everything. It depends. Like if you budget like $2 per month, like cloud probably is not good for you. But if we're talking about big IT projects or I don't know, like middle size, or you start small. Every project starts small, right? Like a startup, but you want to grow and you expect to have growth in the future. Cloud is the way to go today, because it doesn't make sense to honestly to even buy dedicated server and handle everything by yourself. It's like, look, how much is your time? How much costs your time? Think about it, right? Like if infrastructure costs more than your hour of your time, something's wrong. You need to improve your knowledge and make your time more valuable than infrastructure. That's my opinion, right? That's what I'm thinking. But specifically with Jelastic, Jelastic stands for freedom of choice and fair pricing. We invented pay-per-use. It means you don't pay for the limits. You don't worry about this right sizing problem anymore. So Jelastic saves money for end customers. And there are many different providers around the world. They have different pricing. Like somebody can go very cheap, but please be careful when you choose the most cheapest one, because there is nothing free in the world. So pay attention always on quality of infrastructure and support quality, right? If you can afford cheap infrastructure without moderate quality, it's fine, right? If you are looking for high level quality, choose go for it. So, but again, cloud is necessary today for almost any real project.
All right, that's awesome, Ruslan. That's awesome. Now, I have a slightly different view from Ruslan.
Okay.
Totally everything that Ruslan said.
It's fine. It's fine.
Yeah, I just want to say one thing, guys. So a lot of us developers, right? It doesn't matter if you're big companies or small companies, we have been relying for literally decades on Moore's law, right? Moore's law guarantees that we use new technology, we use new tools, we put more animation application, we do all these kind of cool features, right? And Moore's law always saves us in the end, right? Because while we're developing, the systems are getting faster and faster and faster. But let me tell you one secret, right? I wrote this in an email these last few days for you guys, but Moore's law is getting to the end, right? A lot of people saying that Moore's law is gonna end this year to 2020. But even if Moore's law continues to hold true, the truth is since 2006, right? So I mean that's the last 14 years, the performance of a single thread application has plateaued, right? I mean, it didn't plateau in 2006, and it's plateauing slowly, and it's pretty much flat right now. That means in a single thread application, you're not getting any performance gain from the hardware. So you need to run multiple threads. You need to run multiple CPUs. You need to run multiple machines in your application. You can't get away from this, right? And so, if you can't get away from this, and you have to run multiple machines, what are you going to do? This? You're going to buy lots of machines and put in your backyard? No, man, you got to move to the cloud. So if you're not in the cloud yet, right, you got to do this, because in the next few years, this is the way for us to have performance in application, right? So that's a good thing. And I think this, the more you're able to explain that to your customers, Yosef, even to a small client, right? The more you're able to explain that to them, the better they're going to be going forward, right? And so Ride says one thing. Oh man, there's lots of questions here. Ride says one thing. I think it's a question, Ruslan. He says, is Windows support for Jelastic being developed, right? But I think you guys do support Windows, right?
So it was, let's say, in silent mode. I can open some secrets. It will be, I hope, let's say, announced in Q4. So this year, we have customers, partners that are running in closed private beta mode already. So before we go public, we always try to make sure everything is going well. For example, Fabio, the fast today from Saving Cloud in Brazil, he can offer you access to Windows environments today, actually, right? It's not available at any other provider. But again, we are planning to release this feature at the end of this year, if everything goes well. Again, it's hard to guarantee, because if my QA department, our QA departments, finds some bugs and say better to wait a little bit more, we will wait, right? It depends, of course. Quality is number one for us. Yeah, but so far so good. We are moving forward with a good progress. And I hope we will have a good gift at the end of the year for Windows workloads.
All right. So Fabio from Saving Cloud is saying that we have Windows environments running in Jelastic today, and we have lots of customers doing this, right? So some customers doing this.
Correct.
That's a good thing right there. So yeah, you can run Windows application in Jelastic, right, Ruslan?
Correct. Yeah. So we are working with Fabio very closely. So Fabio is our trusted partner. We have very good connection. So this is the reason why we gave him first. It works fine. It's stable. So we just polishing some UI, trying to improve user experience. So we need a little bit more time to make it full production ready.
All right. Very, very cool. So Konstantin asks, fog computing is rising. Does Jelastic provide any features for that?
So for computing is rising. Look, today Jelastic, it's network of independent and distributed local service providers around the world. It's already the fog, by the way. So it's no central place. You go to Brazil, you find couple partners in Brazil. You go to Switzerland, 5 different partners there, and the beauty of this, it's the same API. You can deploy to all of them in parallel, and another beauty, they're managed by local providers, and they are regulated by local laws. Security is high. I mean, regulations, data privacy, it's very good. We don't touch data without permission of our provider or end customer at all. And nobody can, actually. So it's already distributed, some kind of we will go to later. So for now, let us deal with data centers, right? Later we will go to smaller devices as well. But for now, we are focusing on data centers workloads.
All right, that's cool, man. Awesome. So, I mean, we're getting lots of questions about Jelastic. I thought I was going to get lots of questions about the cloud, right? But then we can't get lots of questions for you specifically, Ruslan. So, Paolo says, I know there's a lot of public cloud providers offering Jelastic, but the TCO is too high for small business in some countries. So then he says, I think he says here, there's this, there's a barrier for small, medium companies, right? Maybe offering a cheaper private cloud license can be a small step, right, to install on a cheaper VPS. But that's, Ruslan, that's not my experience that I get a lot, right?
No,
My experience is that actually when running, because I'm a small company, Paulo. So Paulo, let me say this: I'm a small company, and my experience is that for me is actually a lot cheaper to run things on Jelastic than it is to run in other places, right? So so maybe that's an interesting data point there. And I think the cool stuff for me is that I don't have to be worried about how much resource I'm paying. I just put how much, what's my maximum, right? And then Jelastic only charges me for exactly what I'm using, right? So I think this is actually a pre return on investment right there, man. So, but I understand that there are some things, but if just wait, Paulo, because we're gonna be doing a cool stuff here this week, right? We're gonna because since we're gonna be spend the whole week here doing a masterclass with you guys, I'm wrestling Ruslan to try to get as much from him this week that I can. So I'm gonna use your comment, Paulo, to see what else can I do for you guys this week, right? So I have a meeting with Ruslan right after we finish this here. So I'm gonna work with him to see if we can do more for you, Paulo. Okay, let's wait the week going on, and we see what we can do, right? Paulo says the problem is having hungry JVMs, right? So I need several reserved cloudlets just for a single instance. But we already talked about this today, right? So Ruslan, do you have any solution for that?
Several cloudlets. How much several? Is it 3 or like 30? Like, so it depends again. Like, so 3 cloudlets probably it's still still Java is elastic now, but it requires some minimum. Like, you cannot go 0. Like, it's if you want to save resources, there is a possibility to install add-on that just brings down your application during the night, even so you just set up wake up at 9 a.m. and bring down at 6 p.m. So you pay for 1/3 of the day, and for just 3 cloudlets, it should be fine. Yeah, with Java, take insight what exactly version you are running. So are you running on top of our certified containers, or you are running your custom Docker container? Because it can be different. If you're running our certified container, then we optimize stuff, and it can be lower. Usage can be lower, but of course it depends what you run inside. How much heap memory is used by your application. So look, 3 cloudlets is still not too much, but maybe there is a possibility to go a little bit down. If you are talking about big amount, then just send me message. We will figure out why it's like this. By default, it's not going to use, if your application is not hungry by itself. Jelastic is not using a lot.
All right. So Miguel is asking I think it's a pretty interesting specific question here. So he says that I have some customers using Azure and AWS, but they're afraid about switching to Elastic because of tier 3 certifications and others of that kind. Does Jelastic have the same kind of certification? So look, this is completely outside of my knowledge. So what
I can tell you. It's about data center certification.
Explain to us what that means, Ruslan.
Yeah, so look, we have different partners, and it depends on the partner. We are a software company. We collaborate with different partners. We have wide range of partners, and many of them have tier 3 certification. I am pretty sure. I don't know if Fabio can confirm his certification range, but we can find the tier 3 certified partner. Just send request to info@jelastic.com and state your requirements, and we will find you this certified partner. For some reason in your region we don't have certified partner right now, there is a possibility to run your own virtual private cloud. So we will go together with you and find a data center with required tier in your country, and then we can and provide managed services directly to you. It makes sense in case if you have medium and large size workloads, right? Because if it's small, like it doesn't make sense because it will cost you more than just like go to public cloud. But if you have like medium, large size projects, and we are missing someone in the country, I mean, like we don't have a tier 3 partner in the country, there's a possibility to go with virtual private cloud. So Jelastic will manage cloud for you. And believe me, like you will get much better performance than you get today, like on Amazon, on Azure, on other clouds, because it will run on top of bare metal. It will be cost efficient, and you will be able to put more workloads on the same size of infrastructure because our density is super high comparing to like just public clouds. So there is a possibility. Again, it depends on your expectations and on your requirements. So it will be good to get these details at info@jelastic.com.
All right, that's awesome, man. That's great. Okay, so look, let me tell you this: if you are participating on the Cloud Tech Days initiative already, Paulo, so if you receive our emails, I'm sorry, Miguel. So Miguel, if you're not on the Cloud Tech Days, please go join cloudtechdays.com right now, because you're gonna get once you register there, you get an email from Ruslan, right? So you just reply to the email, Ruslan, I'm Miguel, the guy that talked to you on the
exactly
on call, and I really need a tier 3 certified partner. So Ruslan is gonna help you out with that. That's awesome. So Maicon is saying here that he's proud of Brazil, right? Say having people that represent. So let me tell you this one thing, Maicon. Ruslan, this guy here, he came to Brazil, I don't know, maybe 2 years ago, 3 years ago, and we traveled with him to like 10 different cities. We drove cars all over the country to go to all kinds of places. And I was talking to Ruslan last week, and we were arranging for him to travel again here to Brazil, to come here and do even more activities here in Brazil, right? So Maicon, that's great to have you here, and lots of the Brazilians. Actually, we have Fabio from Saving Cloud is a Brazilian running things here in Brazil too. We have lots of cloud specialists in Brazil. I think I'm very, very proud of our cloud community here. So that's awesome.
Yeah.
All right. So Ruslan, I don't see any more questions here, and I'm not sure if you have anything else to present or.
Yeah, demo, guys. You want a demo? Like I can do a quick demo about scaling, like so how scalability works exactly in Jelastic. Like so you will get the understanding like how we build it. Okay.
All right, let's do a quick demo. And by the way, all of you can go ahead and ask questions anytime you want here in the chat. I'm gonna be moderating here. So let me get Ruslan do a quick demo for us here then.
Yeah, so look guys, like vertical scaling, right? So do you see my dashboard? Bruno, can you confirm it's visible?
Yes, we can see your dashboard, yes.
Okay, very good.
It's a little small. The font's a little small. If you could make it a little larger, but yeah.
Like this probably, yeah.
If needed. I'm not sure if people need to read things. So yeah. All right. That's better.
Okay. So we have like this button, right? Like green button, new environment. So each application needs an environment. Environment consists of.
Before you go, Ruslan, Miguel is saying here, great, right? I'm registered for the event. I'm interested in private cloud, and if I could talk more, Ruslan would be awesome. So Miguel, don't worry, man. We're gonna figure out lots of different ways for you to come talk with us. And let's figure out ways to talk more. Thanks, man.
Yeah. Cool. So we have this topology wizard, like we call topology wizard. It's like, control panel for dev guy, like, right? And what we have here, we have like all languages, right? Like Java, PHP, Ruby, .NET, Node.js, Python, Go, and we have even custom Docker containers, right? Let's start from Java. You can choose different software stacks here, right, with different versions. All of them are certified here. I mean, we tested them. They work by default, and they optimize it for cost efficiency. And now about vertical scaling. So every container, right, can be scaled vertically. You add just resources on the fly. Like, so look, it's pretty easy. Like I just drag and drop, right? And my container now will have like 16 GB of RAM. There is a limit which is defined by your cloud service provider. But if you need more resources per one container, you can just contact your cloud service provider and explain like why you need it, like, and how much exactly you need. But by default, there is a specific limit, so you can go like up to this limit. This is vertical scaling, and then we can go like horizontal scaling. So you can just click plus button, like 1, 2, 3, 4. Let's put like 16 as well, like, right? So we can create 16 containers. And there is a button, another one, drop down. I explain it like what kind of scaling you want, stateful or stateless, right? With stateful, we will clone the leader container, like the main container, one by one and migrate to other physical nodes. And with stateless approach, we will create all containers in parallel from a master template. It will be faster to do it in stateless mode. But if you already did something, some kind of deployment or configuration, like so, I suggest to go like stateful mode. So let's scale it to 4 and stateful mode. Yeah, and let's keep it, let's say like 8 GB, right? And I can choose again like GDK version, what I want, and that's it. Actually, for scalability, pretty easy, right? Like vertical and horizontal scaling just in a few clicks. And as you can see, by default, as soon as you add more than one container, we add load balancer for you. In this case, it's Nginx, and you can scale this load balancer as well, vertically or horizontally. So you can have like multiple load balancers, right? Let's leave 2, and let's make it stateless. And yeah, but if you don't like Nginx or you need something else, there is another set of load balancers available. And same for databases, right? Like I like, for example, MariaDB very much, right? Because founder of MariaDB is my friend. And you can do the same, like vertical scaling here, right? And then you can do like horizontal scaling. But databases scaling is more tricky, and we suggest you to go with auto clustering mode. So you just press a button, and we will configure auto cluster mode for you. So there are different topologies like master, master slave. Sorry, it should be renamed due to like the recent issues, but there is also like Galera cluster, which is multi-master one. And yeah, like I just choose this Galera cluster. I don't need to worry about how to configure this clustering and how to configure load balancing, like easy. So Jelastic is all about easy. And yeah, let's create this one like test environment. Let's put it like this, yeah. By the way, I can choose region. Like for example, this is demo cluster, right? So we install it on top of different providers, like on OVH, servers.com, like a couple more regions from OVH from different locations, right? It's our just demo cluster we use to show some demonstrations, right? And run some own projects. So I will choose premium region, and again, like I just press a button, and in a couple minutes my environment will be ready. But how to configure horizontal auto scaling? I have another environment here, right? I go like a button here, like setting, right? And then I go to auto horizontal scaling, and then I press a button add. And now I have more buttons here, like CPU, memory, network, disk, IO, and IOPS. And it's pretty easy. Like, so look, I choose which layer I want to scale, like load balancer or application server. Let's say application server. I say like, please, I go to memory. I say like, add more node. Yeah, so add more node when you want to scale it up and down, like so. I got notifications, so don't tell every secret now, like because we will have more sessions specifically about this. Again, like just show you like it's possible to do. It's pretty easy and done. And a good thing, coming back to our presentation, when you scale this, these containers are distributed proportionally across physical nodes available in the cluster. So we call it anti-affinity, right? So all tomcats are located in different nodes. databases and different nodes, and load balancers and different nodes. So yeah, and this is again like automatic horizontal scaling. It's also possible to attach your custom events. It's for more advanced project like that want to do like extra stuff during the scaling, like or before the scaling. We have like cloud scripting logic where you can export and import this logic here, right? And add additional automation. Like it's again like it's for more advanced. When you've done it manually, then you can move to automation level, and you can build very advanced continuous integration, continuous delivery pipeline. You can build custom. You can attach custom actions for scaling events. So at the end, it's pretty easy, it's scalable, it's efficient. Like about efficiency, we will talk at another session. Like I will show you how to save money with Elastic and what is the difference. And just you know, like some small tips here. Now look how big is this scaling range. We have limits like 12 gigabyte, right? But my container is using only 220 megabytes. And with Elastic, is only 220 megabytes is charged. If you go to like other cloud vendors, like they will charge you for 12 gigabytes, which is not fair from our point of view. And Bruno can confirm that this model works perfectly, like, right? So it saves a lot of money. You don't need to think about your limits anymore. Like you just put high limits and you enjoy your availability and scaling. This is, guys, in short.
Let me say this, Ruslan, it works very well. Yeah, we use this. And we're very happy with it. So you know, this is it's a lot. It's you know, doing scalability like this, it's a lot easier, right? Especially because the fact that we can scale horizontally, I mean vertically, right, as much as we want. So that makes it a lot easier, especially for applications that are not done to scale horizontally, right? So you don't have load balance anything built in your application. You can scale vertically. That's an awesome way to do it. Yeah.
Correct. Good, guys. So that was in short about scaling. Questions and who are signed up for our Cloud Tech Days. We'll send our materials and we will send follow-ups. More questions, please feel free to reply directly to me. You will receive email from me. Yeah, DevOps with GitLab, we have such kind of demo as well. So again, like just request what you want to learn more, and I or my team will prepare materials and follow up. And again, like we'll help you first of all to upgrade your knowledge, to make you a better expert. You will be able to earn more, right, and spend less time. And second, you will be able to learn to use cloud in a proper way, like to save money, to use advanced features for automation, automating scalability and elasticity. So that's in short. Good. Any other questions? So we have one more idea for a future demo. Yeah, DevOps with GitLab and GitLab and GitHub. Definitely, we have nice GitLab package here in marketplace. I just cannot show everything. Like we have like GitHub demo and GitLab demo.
So how about Ruslan, that we show, you know, when you talk about because we should talk about pipeline a little bit, right, during this week.
Right. For sure. Yeah, for sure. Yeah, pipeline, continuous integration, continuous delivery. It's a proper way to relax at the end, you know, at the beach, like while your work is done by computers, like, you know.
Right. So Ruslan, let me ask one thing. Pipeline is something that we're going to talk on simplicity, or is pipeline going to talk about on price, on saving?
Simplicity, man. Simplicity.
All right. So then we're going to do. Yeah, we're going to do a pipeline demo on Friday then, right? Friday is the day we're going to talk about simplicity. And so we can do a pipeline demo on Friday. How about this, Paulo? Paulo's saying great, so that's good. All right. So there's a discussion here. The Brazilian government should use that to their apps, right? Yeah, you know, we had some problems we had some problems with the local elections yesterday, but you know, who doesn't, right? Right now, who doesn't have problems with local election, right? So, you know, but yes, you know, if you maybe that could be something interesting for the Brazilian government for sure. Some users prefer fixed billing to prevent a bill shock, right? Well, what do you talk about in terms of bill shock? And look, Hidre, I can tell you, having had some bill shocks since I started using the cloud in the past, right? So let me tell you this one thing, man. When all you're paying is for exactly the resources you're using, you're not paying anything extra for any extra resources. Being worried about bill shock is a lot less important, because I'm only paying for a lot of resources if my app is using a lot of resources just for a few minutes, right? And so that's a lot better for you to do. And I understand the idea of fixed billing, and I think it might be possible, right? But fixed billing, it's about charging at the top, right? It's not about charging at the minimum. So the idea is that if I go on Gelask and I say, look, the maximum that I want to pay is this, Gelask will not charge you this. They're going to charge you how much your application actually use. So you don't have a bill shock because you know the maximum, right? You know exactly what is the maximum. But Gelask is always going to charge you less than the maximum because they only charge for what your application uses. So I think that's pretty awesome. So it's much better than fixed billing, because you put, you say, I'm not going to pay more than this, but then Gelask charges less most of the time. So how about this? I think that's better.
Yeah, exactly. So we can offer fixed, but look, like after you realize how flexible it's working, you will not want to go back, because like you will overpay. Like, man, we are fine to get more money, like, but do you want us to, to overcharge you? Like, nobody wants to overpay. This is the reason why we introduced this pay-per-use. And even look, like, why bill shock might happen, like if you get a big traffic, but it's good, man. Like, there are only two reasons why you can get big traffic. First, like, you got very big popularity, right? You got demand. Like, it's a great problem. Like, you don't want to have downtime during this time. Like, even like you pay more, like most likely you will earn more, because like your service is getting demand, like, and during the time, like, you can optimize, like, for a higher load. So it's good that there is this flexibility. And second reason, if somebody is attacking you, right, like there is a DDoS attack, but it's another kind of problem, like you have to solve it, and you will get notification that like your usage has been significantly increased, like during the last hour. So you will be able to react, like, so you will not wait till the end of the month, like till the bill comes, like, you will be able to jump immediately and see what's going on, like maybe, to protect your application if it's attacked by somebody, like. So there is really like this pain is in mind only, like in fixed bills, it's like horses and cars, In the past, people said like, cars are not good, like horses are better, like, or even like jump from cars to airplanes, like. So it's the next level. It's the next generation billing model, and other clouds started to promote and to introduce it, like. And remember my words, like, it will be like the only model, like not a fixed one. Maybe again like small packages or something like this. Like always, Bruno said very good word, like, when it's fixed, like it means they charge you more than you consume. None service providers will give you more than you pay, like, none, because it just does not work with the business model. Yeah, why reserved actually? There is a question, Bruno.
Yeah. So,
should we go, or maybe we should leave it for like topic about pricing, like, because we are moving to another now I see direction. What do you think?
yeah, we're going to focus here today, Ruslan, on scalability, right? Not on pricing.
Right.
Paolo is kind of saying that, he wants more information on pricing. So let's do this, Paolo.
Come next.
So Paolo asked us two things, Ruslan. He asked a demo of DevOps. So let's do this on Friday when we talk about simplicity, right? And Paolo also asked us on how to save money. So Paolo, we're going to have a whole discussion on saving money on cloud on Wednesday, right? So because look, Paolo, I understand that this is the problem that you have, and the reason is, look, those are the most asked questions about cloud, right? How, pricing, how do I run cloud in a low pricing thing, right? So we're going to discuss this kind of things on Wednesday. And it's not going to be only about Gillespie. We're going to understand how pricing a cloud works, so you can actually discuss this with your cloud provider, whatever they are. And so we're going to work on this on Wednesday. And on Friday, we're going to talk about simplicity, and we're going to discuss. And by the way, on Wednesday, we're going to have Rafael Del Nero, Java champion, and he's an awesome specialist on how you create skills, right? So I mean, he's doing a lot of work on skills creation. So we're going to talk more about how you can actually benefit from the saving and the simplicity and all of that to get your skills moving to the cloud, right, in the right way. So that's going to be awesome on Wednesday. All right. So Ruslan, I think we answered all the questions, man. And
very good. Thank you guys for the questions.
So just so we finish this here, one last thing before we finish here, I just want to make sure that if you're not registered yet for Cloud Tech Days, I want you, just go ahead and register for cloudtechdays.com, because that way you're going to receive material from this program. You're going to receive the invitation for every one of the classes, and we're going to be here with you for the whole week. And you're also going to receive my email, Ruslan email, so you can ask us questions over email. We're going to be more than happy to help you out. And there is a special Facebook group for all of us here, so you can come and participate, so we can have discussions there, you can ask questions there, and we're going to spend the whole week helping you out with cloud. Okay, make sense? So thanks everyone. It's been like more than 2 hours of conversation here today. That's awesome to be here with everyone. And let me just see if there's any more last question here. Paulo says, okay, thanks, awesome. And Hidre say thank you, and this makes sense. Awesome. So thanks everyone for being here. Ruslan, you want to say some last things?
Yeah, guys, thank you for attending. I hope the presentation was helpful for you. We will follow up with additional materials, and please prepare your questions for the next 2 sessions. And looking forward to meet you again in a couple of days.
All right, so that's awesome. So thanks everyone. So great discussion and advice. Says Ride. I mean, I'm definitely saying your names wrong, guys. So Max is saying great, congrats. So awesome. So yeah, we want to answer all your questions this week. So join us on cloudtechdays.com so we can really help you out with all the things. All right, thanks everyone. It was great to have you all here.
Thank you. Bye-bye.
Thanks. Bye.